Bismillahirrahmanirrahim, and very good evening to all of you. I hope you had a good day. In this video, I'm going to explain the fundamental equation of demand theory, or the Slutsky equation. So the relationship between the total effect, or price effect, substitution effect, and income effects of a price change are summarized in the Slutsky equation. The Slutsky equation is also known as the fundamental equation of the demand theory, and Slutsky equation can be defined as follows. Let x function of all prices and income level of the consumer be the consumer's Marshallian demand system, and let U star be the level of utility the consumer achieves at prices P, where P is vector of prices of goods, and income Y. Then we get this equation, which is a partial of xi with respect to Pj, that is equal to partial of Hicksian demand function with respect to Pj minus xj times partial of xi with respect to income. And this shows that the left hand side of this equation is total effect. The first term on the right hand side is the substitution effect, and the last term on the right hand side is the income effect. And here I and j varies from 1 to n. The proof of this remarkable theorem is quite easy. Let us begin by recalling one of the links between Hicksian and Marshallian demand functions. We know that Hicksian demand function can be obtained by substituting the value of the expenditure function in the Marshallian demand function for any prices and level of utility U star. Because this holds for all prices which are strictly positive, we can differentiate both sides with respect to Pj, and the equality is preserved. Interestingly, the Hicksian demand on the left hand side, because it depends only directly on prices, is straightforward to differentiate. The Marshallian demand on the right hand side, however, depends directly on prices through its price argument, but it also depends indirectly on prices through the expenditure function in its income argument. We will have to apply the chain rule to differentiate the right hand side. Keeping this in mind, we obtain the following. So we get this equation, which we call P1, that is partial of the Hicksian demand function with respect to Pj is equal to partial of the Marshallian demand with respect to Pj plus partial of xi with respect to income times partial of expenditure function with respect to Pj. Now, if you look at this equation carefully and remember the significance of the original level of utility U star, we can make some critical situations. By assumption, U star is the utility the consumer achieves facing price factor P and income level Y. Therefore, U star is equal to V of prices and Y, that is indirect utility function. The minimum expenditure at prices P and utility level U star, therefore will be the same as the minimum expenditure and prices P and utility V of price factors and income level Y. We know that the minimum expenditures at price P, where P is the vector of prices, and maximum utility that can be obtained at prices P and income Y is equal to income Y. So we have that the expenditure function at price factor P and utility level U star is equal to expenditure function in which we substitute indirect utility function, and that is equal to Y, and we call this P2. It is clear that the partial derivative with respect to Pj of the expenditure function in P1 above is just the Hicksian demand for good I at utility U star, because U star is equal to V of Py This must also be the Hicksian demand for good J at utility Vp, where P is the price vectors and Y is the income. Or we have this, the partial of expenditure function with respect to Pj, and that is equal to xjh, the Hicksian demand function for jth good, which is also equal to xjh, which is a function of prices directly and prices indirectly in indirect utility function. So we know from the duality between the Marshallian and Hicksian demand functions that the Hicksian demand at P and the maximum utility achieved at prices vector P and Y is in turn equal to the Marshallian demand at P and Y. Thus we have that the partial of the expenditure function with respect to Pj is equal to xj py, and we call this P3. To complete the proof, we substitute P2 and P3 into P1 to obtain dxih del xih or del pj is equal to del xi or del py, del pj plus partial of xi with respect to partial of y times xj, where xj is a function of prices vector and income. Rearranging a little bit, we have what we wanted to know or wanted to show, and that is the famous Slutsky equation, which is given in this equation. So Slutsky equation or Slutsky equations provide a clear analytical expression for substitution and income effects. They also give us an accounting framework detailing how these must combine to explain any total effect of a given price change. After all, the only thing we have done so far is decompose an observable total effect into an observable income effect and an unobservable substitution effect. For example, consider what Slutsky tells us about the special case of an own price change. We have that this equation, which is Slutsky famous equation or the fundamental law of demand theory. The term on the left is the slope of the Marshallian demand curve for good I, this one, and that is the response of quantity demanded to change in own price, so xi and pi, and this is what we want to explain. To do that, however, we apparently need to know something about the first term on the right hand, this one. This, however, is the slope of the Hicksian demand curve, and Hicksian demand curves are not directly observable. What can we know about Hicksian demand curves when we cannot even see them? Surprisingly, our theory tells us quite a bit about Hicksian demands and so quite a bit about substitution terms, whether we can see them or not. It means even if we don't see Hicksian demand curves, our theory helps us how we can explain this. So whatever we learn about substitution terms then can be translated into knowledge about observable Marshallian demands via the Slutsky equations. This is how the Slutsky equations help us, and this is our strategy to know. So we begin with the preliminary result on own price effects that gives a hint of what is to come, and we start with the negative own substitution terms. Let us suppose the xih of price vectors and given utility be the Hicksian demand for good I. Then the partial of Hicksian demand with respect to own price is less than or equal to 0 for all I from 1 to up to n. This theorem tells us that the Hicksian demand curves must always be negatively sloped with respect to their own prices, and that is true. I just did this in the previous video. The proof is quite easy. The derivative property of the expenditure functions tells us that for any price vectors P and U, the partial of the expenditure function with respect to own price gives us the Hicksian demand function xih, which is a function of the price vector, prices vector, and utility u. Now, if you differentiate again with respect to pi, it shows that del square of the expenditure function divided by del pi square is equal to partial derivative of the Hicksian demand function with respect to own price for all I varies from 1 to 2 up to n. Since the expenditure function is concave function of prices vector, therefore, by theorem, all of its second order own partial derivatives are non-positive. And it proves our theorem. So it means that the Hicksian demand functions, the Hicksian demand function with respect to its own price is less than or equal to 0. It's non-positive. So this arrow shows this theorem. Let us now discuss slightly the law of demand. It means that a decrease in own price of a normal good will cause quantity demanded to increase. If an own price decrease causes a decrease in quantity demanded, the good must be an inferior good. Similarly, in stating the law, we use some familiar terminology. A good is called normal if consumption of it increases as income increases, holding prices constant. On the other hand, a good is called inferior if consumption of it declines as income increases, holding prices constant. So these are some new terminologies that you can learn or you have learned so far in this video. Let us now discuss some of the elasticities of demand and income share of various goods. So we start with the Marshallian demand for good I, which is given by xi of py. Then let eta I is identical to the partial derivative of the Marshallian demand function with respect to income times y divided by xi at prices p and income y, and epsilon ij is equal to partial of the Marshallian demand function with respect to pj times pj divided by xi. So we may think of this as a income elasticity of demand and this as a cross price elasticity of demand. And let us suppose Si is the income share or the consumption spent on Xi. So this is basically the consumption share. So that Si is positive, that is greater than or equal to 0, and summation I varies from 1 to n, Si is equal to 1. So it means that if we sum up the share income share of various goods or the expenditure on various goods, then the share basically will be equal to 1. So it says that the symbol eta I denotes the income elasticity of demand for good I, and it measures the percentage change in the quantity of I demanded per 1% change in income. Similarly, the symbol epsilon ij denotes the price elasticity of demand for good I and measures the percentage change in the quantity of I demanded per 1% change in the price of jth commodity. If j is equal to 1, then Eij or epsilon ij is called own price elasticity of demand for good I. If j is not equal to 1, then these are called the cross price elasticities of demand for good I with respect to price of jth good. And the symbol Si denotes the income share or the proportion of the consumer income spent on the purchases of good I. So if we sum up the income share or the proportion of consumer income spent on various goods, then that sum will be equal to 1. And these must be, of course, be non-negative and sum to 1. Ladies and gentlemen, this is a very informative and interesting video on how Slutsky equation helps us in explaining the substitution and income effect. I hope you liked it. Kindly subscribe to this channel and don't forget to click on the bell icon so that you can get regular notifications about my videos that I'll upload for you soon. Thanks for watching and see you in another video. But don't forget to share various videos of this channel in various WhatsApp groups so that this could reach to the maximum possible number of people. Thanks for watching and see you in another video.